When we look at perpendicular bisectors, we start with the perpendicular bisector theorem. And that tells us if I have a perpendicular bisector here, CD, to segment AB, meaning it's both perpendicular and hits at a midpoint D, that any point that I put on that perpendicular bisector is going to be equidistant to the endpoints. So we have point C here, and let's say I write another point E. Well, that's going to be equidistant to A and B also. And if I put another point here and call it F, that's going to be equidistant also. So no matter where I put this point, it's always equidistant to it. Now this is very much so based in our triangle congruences. If I drew this diagram and with the right angles and reflexive, I get a side angle side congruence. And by that side angle side congruence, I know those two parts are congruent because corresponding parts of congruent triangles are congruent. So now we've given it context, call it perpendicular bisectors. The converse of the perpendicular bisector theorem tells us if we have this point that's equidistant to A and B, then we drop a side down or a line down and hit the line. It will hit so that it is a right angle and that it is a midpoint. So we reversed the order of that. Now, we then take those perpendicular bisectors and put them within a triangle. So I have all three sides. I've drawn perpendicular bisectors. They meet at a point that we call the circumcenter. The circumcenter we also find is equidistant to the vertices of the triangle. So all three perpendicular bisectors meet at the point, and then they're equidistant out to the vertices. So our bisectors are PD, PE, and PF. Our incenter is P, and then the congruent segments go from there. We'll come back to that in a little bit, but let's look at just solving with perpendicular bisectors. I need to find MN. Here's my perpendicular bisector. So 4x plus 19 equals 6x minus 7. I subtract 4x from both sides. I add 7. And I get x equals 13. We then take 13 and substitute in to MN, which is 4 times 13 plus 19, which gives us 52 plus 19, or 71. For the next one, JL, this idea is using the converse, but these are equivalent parts. So 3x plus 4 equals 5x minus 16. We subtract 3x from both sides. We then add 16 to both sides. And we get to x equals 10. Now if x equals 10 and I substitute into both of these, I get 34 and 34. What we're looking for is JL. JL is the sum of both parts, or if we take one of the parts, we double it, because it is a midpoint, we get 68 units. In our next problem, we have a bisector again. RT bisects SU. So we know these are equivalent. We need to find the measures. So ST, if we've covered up this portion, we have a perpendicular bisector. ST and TU are the same, so that's 23. For RU, we've covered up this side of it. Again, perpendicular bisector. Top part's 8, bottom part's 8. SV is a midpoint up V on SU, so if this portion's 5, this portion's 5. And then SU is the total of the two. We'd call that 10. For our next one, we need to find x. That is our perpendicular bisector again. 24x minus 19 equals 16x plus 13. We subtract 16x from both sides. We then add 19. We get 32 on the right, so that gives us x is 4. If we needed to, we could substitute back in, but right here it's just looking for x. Moving down, we have QT is a perpendicular bisector of PR. We also have that S is equidistant from those 2 points. So really we kind of have like this half and this half. We can match up corresponding parts and find equivalence. First thing we're going to find is x, and that's these two values. So 4x plus 4 equals 7x minus 17. And solving that, we get 3x equals 21, or x equals 7. Then we can also solve for y with these two values. 5y minus 31 equals 2y plus 5. Subtract 2y, we get 3y. Add 31, we get 36. So y equals 12. Now, we need to go in and start finding parts. PQ, if we substitute in the 12, is 5 times 12 minus 31, which is 60 minus 31, or 29. So 29 here. If we asked for QR, it would also be 29, which we are. That's 29. What else do we need? PS is this portion, so we're going to use X for PS. We get 4 times 7 plus 4. That's 28 plus 4, which is 32, which would also be SR. Last part, we need PT. Well, that requires both X and Y. So we know 6 times 7 minus 2 times 12. That's 42 minus 24. And that looks like 18 for PT. Then when it asked for PR, because this is a midpoint, we know that TR is also 18, and we would get 36. For the next one, we have Z as the circumcenter, and we're going to find each measure. Now we have to remember the circumcenter not only is equidistant to the vertices, so these three values would be the same, it's also midpoints. So if I have 19, we'd have 19 here as well. If 34, these would both be 17, and then the 21 would be all three of those parts. So now when we look, TU is the whole length of the side, that's 19 and 19. So that's 38. VY is 17, it's half of 34. And UZ would be 21 because it's the equivalent of ZV and ZT.